Okay, I think we're recording. So thank you all for joining. Based on the little poll we had, looks like there's a fair bit of support, fair bit of interest in learning how the Maven feeds work. And so that's what we'll be diving in here today. So the overview of this will be, what is Maven? What do Maven feeds look like? How do you debug access to Maven? And a couple of other little tips and tricks along the way. So to start with, I guess the first question to answer is, what actually is Maven? And so Maven is more of an ecosystem of tools and platforms than a single thing. But at a high level, you can think of Maven as being a way of defining Java projects. And so they are typically defined in these files called Pom.xml. Pom stands for Project Object Model, I believe. And so this is an XML file that defines all the dependencies, configures various plugins, and sets up different repositories. And so this is how you typically build this is one of the ways that you can build a Java project. So it is also a command line tool. So there is the NBN tool. And this is the command line tool that will build or read those pom.xml files and do something useful with them. And the third bit is the package repositories. And so what you can see here is all these dependencies. They'll all exist in a Maven repository somewhere. And as part of building a project, Maven will go in and download these dependencies. You can also store complete built applications in Maven as well. So it's not strictly just for libraries. Final and complete applications can also be stored in Maven. And so this is a sample application, one of those samples that we typically use in documentation. And this pom.xml shows off a bunch of different dependencies. And so this dependency here, don't worry about too much what it is specifically, but what we can see is that the dependencies themselves have group IDs, and these are usually like reversed DNS names. That's not a strict requirement, but that's a fairly typical practice. It has an artifact ID, and then they'll also have versions. This one doesn't have a version because it's inheriting versions from up here. But this group, artifact ID, and version, this combination of three things are what basically the minimum that you need to define a particular artifact in a Maven repository. And so the default Maven repository is called Maven Central. And that's this one here. And so Maven Central is just a kind of a free and default repository that almost all open source projects place their artifacts into. So you can host your own repositories. There are software packages available that will do that for you. But as you'll see, actually you don't even need any special software, because Maven is, the Maven repository is actually just a particular structure of files. There is no server as such beyond really a web server, and there's no API. It's just an agreed upon pattern of directories and files that allow a Maven repository to function with clients. And so we can see that here. I've taken the Spring Boot web starter, which is this one, and found the artifacts in Maven Central just based on the name. Sorry, it's actually this one here. And so what we have are the group ID. So I've taken this org.springframework.boot, appended it to the end of the Maven Central URL, and just replaced the dots with slashes. So that's this bit here, org/framework/boot. And then we've taken the artifact ID as a single string and put it on the end. And then we've taken the version which again was inherited from here, and place it on the end. So this URL structure is how Maven will find this particular artifact in Maven Central, and it will default to Maven Central to try and find it first. And so actually I'll jump back to the top level just quickly so you can kind of see how everything's structured. And again, so these are all the open source projects that people have contributed to Maven. And as you can see, there's a lot of these reverse DNS directory structures. So Google has a bunch of libraries. So we've got the reverse of google.com. We've got the library name called Guava. And then we've got some versions here. But I'll just go back to this one for now. But what you can see there is actually all I'm doing to navigate the structure is just browse a web directory. There's no special tools here that are required. It's all just, in this case, it's all just HTTP access. So there are a couple of files that we want to pay attention to. The first one is this Maven metadata.xml. And so this sits at the level of the group and then the ID. And then you'll have this Maven metadata.xml file. And so this file is like an index, and it lists all the versions with the latest one that are available on the server. And so this is one way. This is actually how Octopus collects the available versions of a package. It will construct this URL, get the maven.metadata XML file, and then read these versions, and that's the list that we present to the user. And then if we jump into a particular release, you can see that the individual artifacts are now in this directory, and there's no deeper directory structure than this. This is where everything lives. So there's a couple of things here that are important. You'll notice that so this one here, the .jar file, this is the actual library that you'd almost always be using. That file is what this dependency is referencing by default, the jar file. But we also have other files. We have so we have sources, and that is the source code actually that relates to this particular package. There's a couple of signing files here, so that ASC will be a signature, MD5 again, and another what's the word I'm looking for? You know what I'm talking about anyway. The word will come to me. But yeah, so the main ones in this file are the jar file and the sources here. And so this the way this works is the jar file, that's called the default artifact. And these other ones with the dashes on the end, so dash sources, for example, these are specific secondary artifacts. And so the sources part of this file here is referred to as the classifier. And so that's probably, I mean, that's going to be different than most other repository types, I think. The idea that you can have this primary and secondary files side by side. Most artifacts, most repositories tend to just have the primary artifact, and that's it. Like that's what you reference, and there's nothing sitting alongside it. So we'll see how that's important later on, but it's just worth noting that this is very common. Sources, the default one, things like sources, and you quite often have like Java docs as well, side by side. So that's just the code documentation. So that there was an example of just a library that you typically consume when building an application, but as an example of a complete built application also being stored in Maven, we have this. And so this is actually the built version of this application here, and we've pushed it up to Maven Central. So this WAR file, WAR stands for Web Archive. This is the application that you would be deploying. You wouldn't typically reference this as a dependency of any other application. This is actually what's going to sit on your server and run an application. And these sorts of files are what Octopus is most concerned about. So we don't really concern ourselves with application dependencies, but we do want to be able to deploy the final built application. And again, you can see another example of the default application side by side with these secondary ones. So that's the sources that we saw before, and that's the Java docs that I mentioned previously. So the versions here, you'll notice they're, they're sem-ver-ish, but they tend to be x.y.z. There's another style of versioning that Maven implements, and that's called Snapshot Versions. And Snapshot Versions are used more as a convenience, really, as you continue to develop an application. You don't want to have to necessarily increase the version number every time. So if I'm building 0.8.6 and that's under development, what would normally happen is I'd give it this version of 0.8.6-snapshot, and I would keep republishing that snapshot over and over. And then Maven knows how to, or Maven has options to then pull down the latest version if it doesn't exist. So what you'll see here is that the file names for snapshotted artifacts is slightly different. So if we go here, it's pretty straightforward. It's just the name of the application and then the version number. If we jump in here, we see the same pattern, except on the end, you get this, this additional string here. And so what actually happens in the background is that even though you're republishing a version called this, and you'll tend to reference just this version here if you were to download a dependency, on the server, every push is saved and retained and differentiated by these time-stamped suffixes on the file name. So what you'll notice here is that we just have .war, pom, sources, Java doc. These are all related to the artifact itself. If we jump into the snapshot one, you'll see there's this secondary Maven metadata.xml. And so this contains different information than the one that sits above this level. So I'll just pull this up. No, this is not going to let me. Oh, here we go. Right. So this this version of the Maven metadata.xml sitting alongside the artifacts lists all the snapshotted versions. And so what you'll see is under this snapshotted version element here, the different the file names, I guess, that make up each individual push of that version. And so what we'll do, or what Maven clients will do typically, is grab the last updated one and use these values here to build the name of a file that references the latest snapshot. So the process is read this Maven metadata.xml, extract these values that represent the latest snapshot, and then use that to build up the file name that can then be used to download the latest snapshot. And so that's just something to keep in mind, that the process of downloading one of these non-snapshotted versions and one of these snapshotted versions is slightly different. So this one here, this file name can be completely determined by the group, the artifact, and the version. So you can combine all these values in a known way to arrive at the final path that allows you to download this file. Whereas for a snapshotted version, you do have to run through this extra step of processing this secondary Maven metadata.xml file to get the details of the latest snapshot, which are then used to build up the file name here. So now that I think we've got a reasonably good idea of the kind of, or how a Maven client can access a dependency, We'll jump in and have a look at some of the tools we can use to actually download these files. Actually, before I start, I should say that the directory structure of a Maven repository is fixed. So there's no variation. If you're a Maven repository, you have to conform to these specifications. And so they're documented here on the Maven wiki. And again, you can see this directory structure that I referred to before. The individual components of the group, the artifact ID, the version, and then the file name is built up of the artifact ID and version, and the extension in this case, which will be jar or war. We'll see why that's important later. And these are those secondary artifacts that I talked about, and they have that additional classifier, and that's your Java docs or sources that we saw before. So this is important in debugging because you can be very confident of being able to point people to where a file should be downloadable from. There's no wiggle room actually that I know of in that. So if someone comes up with a support question, says Octopus can't download this file, well, you'll say, well, can you just go to a web browser and download it here? And does that work? That's a good debugging technique. But another debugging technique is to actually use the Maven tool itself. So that's a free download. Most of your package managers, if you're using Linux, will have Maven available, but otherwise you can just go and download it from here. And the executable that we're interested in is called MVN Maven. And so what I'm doing here is using one of the built-in functions of Maven to go and download an individual file from a Maven repository. And in this case, I'm defaulting to Maven Central because I haven't specified a repository anywhere. And so the syntax for, well, one of the syntaxes that Maven has for referencing artifacts is this colon separated syntax here. But again, you can just see it's group, artifact, and version separated by colons. This is just a shorthand that's useful for command line tools, so you don't have to, it just reduces the verbosity of defining all those individual elements. So what I'm saying is get this dependency and save it as a jar file in my temp directory. And so what this is going to prove to us is that, assuming this succeeds, and obviously it did, what this command now proves is that this is a valid artifact and that Maven could go and retrieve that artifact from the server. And so the ability for the Maven command line tool to do this is the gold standard. So if there's ever a situation where Maven can do this, but Octopus can't, it's very likely an Octopus bug. But if you give someone in a support ticket, for example, this command and they can run it, the fact that it's successful will tell you then that the artifact is available and everything is where it is expected to be. The flip side of that, of course, if they can't download it through the Maven command line tool, there's very little chance Octopus will be able to get it. That just, we certainly can't do anything more than what the Maven command line tool does. And there's that file that we downloaded. The command to get a artifact from a non-default repository is basically the same. You just need to specify this remote repositories argument. This command is probably more likely than this one as a debugging tool because almost everyone consuming their own built applications will have their own internal custom repository. So they will almost certainly have to have a URL like this passed into the command line. So what you can see is this is a snapshot version. We've just said we're not referencing any of those suffixes directly. So what you can see is Maven's actually going through grabbing that XML file, it'll parse it for us, and then get the latest copy of that artifact and save it for us. So this is the typically how we reference these snapshots. The individual time-stamped versions, I've never seen anyone have a use case for it. It may come up, but I think it's quite an edge case that you'd ever have to get a particular instance of a snapshot. You're almost always just interested in getting the latest one. So yeah, I'll post these into the channel, but these are good debugging commands just to have in your toolkit. If these issues,
if you're wanting a specific instance of the snapshot, would that be colon separated as well after the snapshot?
That is a good question. I actually don't know what the syntax would be. I'd have to dig into it. Yeah. Yeah, that's right. Look, if I've never had to dig it up, then then I think it's going to be an edge case. I mean, if anyone is asking for that, I think that's something we need to look at the product team. But the short answer is Octopus doesn't let you do that anyway. So there's no built-in functionality in Octopus to get those individual ones. It's a limitation, but it hasn't so far been a limitation that anyone's been concerned with.
Yeah.
So if we jump into Octopus itself, then we can see how these feeds are set up. So here I've set up that Maven Central feed in Octopus. So that's that URL there that I was browsing here. It may not actually be the same. This might be a mirror, but actually right. They'll have the same content anyway. It doesn't matter. They're just one's a mirror of the other. We do support basic auth. The basic auth is just HTTP basic auth. That's what we use. As it turns out, my browser has populated that for me incorrectly, but the anonymous access obviously just ignored my settings there. So the way Octopus references packages is the same kind of shorthand that we used here. We just don't set versions because versions are expected to be provided at deployment time. So if we do that, I think I just saved those credentials incorrectly. Oh no, there we go. It still worked anyway. So as you can see, we use this same shorthand. We've scraped that Maven metadata.xml file, and we found the latest version here. So another important thing to note is that Maven versions are not semver. They can be, like every semver version is a valid Maven version, but quite often the patterns used in Maven aren't semver. And Octopus does support that, so we do have the ability to actually I can probably even show that if we go. I'll try and get that Spring one. So correct me if I'm wrong, but I don't actually think that's valid semver. This dot release is not something you can put in semver, but because Octopus fully supports the Maven versioning schemes, we can grab anything that is a valid Maven version number. The exception to that is if you want to push Java artifacts to the built-in feed. If you're doing that, you do have to have semver compatible packages. The built-in feed doesn't know anything about the Maven versioning strategy, so that's just something to be aware of. So I have my feed, and I've set up this project here as an example of how you might consume those packages. So you can see here, ignore these two at the bottom for now. I've set up 4 additional package references to pull down the different kinds of files that you expect to get from a Maven feed. So we'll start with this one here, com octopus random quotes. So what that's going to do is jump into Maven Central, go to com octopus random quotes, get the version, and then what it's going to do is loop through any supported extensions that Octopus knows about. And so that's going to be zip, tar.gz, tgz, war, jar, a couple of just common extension types. We do actually list all the extensions in the documentation somewhere. So assuming that the repository has one primary package with a supported extension type, Octopus will find it and grab it for you. So you don't need to be specific. If for some reason you had, say, a war and a zip side by side, and that's entirely possible, and you need to be specific about which of these extensions you're going to download, you'd use this format here, com octopus random quotes : war. And so that's going to be specifically then getting the WAR file and ignoring any other primary artifacts of a different extension. And so then we have the ability to get the secondary files, and those secondary files have these classifiers of javadoc and sources. And so what we do here is we say com octopus random quotes, we specify the extension type, they're both jar files, and then classifier. So here you can see we've got sources and javadoc. And so those are how we specifically reference the secondary artifacts. Why
would you need to do that, sorry?
So we've seen cases where certain type of application builds seem to produce these classified secondary artifacts. It's rare. I don't think many people would be using these files. They're just supporting files mostly, but there have been support tickets where people have been caught out by the inability to get these secondary files.
All right.
Yeah, it is rare, but yeah, this is one of the ones. This is one of the edge cases that has come up, so we added support for it.
Cool, thanks.
Right, so this is the output of this particular script. And these are the individual files that we've downloaded here. So you can see that Octopus has successfully grabbed each of the individual files. And these two are the same file, actually. We've just referenced them. This one was referencing the specific extension. This one was the one where Octopus just looped over all the extensions, trying to find one that it recognized. And they both found the WAR file, and they're both the same size. Just be aware that script steps don't have the ability to extract files like these. So even though these are actually zip files, you can just open them up with any zip tool, the script step will actually balk if you selected the option to expand those particular packages. It would just say it doesn't recognize the extensions. The other thing that I did in this, just to kind of as a debugging technique, was to run Maven and run that command that we saw before, get dependency. The only catch here is that because dynamic workers never have this tool installed, I've had to download that zip file and add it as a secondary package. And actually the dynamic workers don't seem to have Java installed either. So what I had to do was go and download a copy of Java, add that as a secondary package, and then set this environment variable. Java home is an environment variable that almost all Java tools respect and understand to be the home directory of the Java installation. So a little bit of mucking around, but this is also handy to know as a debugging technique. And I did this basically as a way of proving that the either the Octopus server or the tentacle, depending on where a particular file is being downloaded, and you get that option to select it, just like you do with any other package, just to prove that the Maven itself could grab that alongside the code we have for Octopus. And there you can see that my file there is what Maven downloaded. So this is all that Maven. Okay, quite a lot. It goes through and tries to get all the dependencies and work out what's important, and then once it's done all that, it'll give you the single file. So that's another useful strategy. What I can prove by running Maven through the tentacle is that all the networking is as I would expect. And so if this command worked and Octopus didn't through a tentacle, then then we probably have a bug that we need to sort out. So that's another good debugging technique. One thing to note is that with Java, there's two distributions. There's the JRE, and that's the Java runtime environment, and the JDK, and that's the Java developer kit. Developer kit is required to run Maven because Maven is a developer tool. It uses a lot of the developer features of Java. So to run Maven, make sure you have the JDK as opposed to the JRE. The other thing to know is that there are many places to get Java from these days. So what happened was Sun originally made Java free. Sun was bought by Oracle. And for a while there, Java was still, the main distribution of Java was still free under Oracle. But over time, what happened is there was this fork in the road. Oracle maintains its own distribution of Java, and it open sourced Java into the OpenJDK project. And then later, Oracle changed the licensing to say that you can't actually use their distribution now in production anymore unless you're willing to pay them. And so what happened is, in response, a whole bunch of projects sprung up to provide easy distributions of OpenJDK. This is one of them, Adopt OpenJDK. This is just generally what I default to when I need to get a JDK. But you may find other companies like Zool, I think, has a free one. So they bundle their own JDK. IBM has one, Red Hat has one. I think even AWS these days has their own distribution of Java that they release to people. So there's a lot of different places to get them. But typically, for our purposes, really, they're all the same. And if you just need to grab one, just go to adopt openjdk.net and grab one. That's the easiest place to go. So in summary, what's important for support people to know when they get a ticket about Maven? So the first thing to do is understand that Octopus will attempt to download these Maven metadata.xml files. So as part of your data gathering, it's good to ask both for this one here, and this one here is the one that lists the versions. And if it's a snapshotted version, ask for this second one here, which lists the snapshots. There are actually different formats of these XML files, and Octopus recognizes the latest one. The previous one is quite old. I've never seen it in the wild, but it may still be out there somewhere. So that's one of the reasons why getting a copy of these files will help us diagnose the issue. So the second thing to do is ask people to run these sort of commands to prove that they can actually download the file with the Maven command line tool. If they can't download it with this, Octopus won't be able to get it. So this is kind of the first step, is to prove that the official tooling can actually get the file, and from there we can determine if Octopus should be able to get it. And then if they're successful, ask the customer to give you the command that they ran, because this here, the versions, the group, the artifact, the versions, the repository URL, these are all things that you can then correlate back into the Octopus configuration to make sure that they're both the same. And then, assuming they can download from the Maven command line tools, you should just make sure that these values here are the same as what they've put into this command here. The only difference, again, is that Octopus doesn't reference the version number in the package IDs. So you can see here that we do group, artifact, optionally the file type, and then optionally the classifier. There's no version number here, and it would fail if you put the version number in. But you can correlate that back to this by just ignoring the version number here, and making sure that this part here is the same. The other thing to do then would be to make sure that this URL is what they've put into the external feed. So that URL from a command should match the URL here. And between those debugging steps, I think you'll have everything you need to either prove an Octopus bug or reverse engineer some incorrect configuration that the customer has put in for themselves. And that's it. That's all I wanted to show off. Did anyone have any questions?
When you create a release in Octopus, what is the package version selector? Is that different with the other standard packages we come across?
The UI is all the same. The only difference here is going to be that the versions listed, these won't necessarily be Semver.
Yeah.
Is that what you're asking, or?
Yeah, basically.
Right.
I think I might just have a play around with it to see, because I was curious about the all the snapshots and the timestamp versions and stuff. So when you select this, it will automatically select the latest timestamped version of the snapshot.
Actually, I'll just do that. Do that quickly. It'll be a good test. So what I'll do is add that that snapshotted feed that I showed in the examples. Oh, that's the wrong place. Let's do that. Let's get rid of that. Okay. So I'll just make sure that feed works. Okay, so we do know that this particular package has a snapshot, and we'll add that to here. Okay. Right, so what's actually going to happen in the background is you don't see those timestamps. Octopus only ever presents this dash snapshot to the user.
Yeah.
But in the background, it knows that it has to read that XML file and get the details of the latest snapshot and download that as the version.
Okay.
Yeah. So from the user's point of view, you don't see those timestamps. It's all just kind of hidden for you. And we assume you're always trying to get the latest.
Yep. Okay, cool.
Yeah, but if anyone does ask about that, certainly reach out, because I don't think it'll happen. But if it does, we should be aware that people have that requirement.
Cool. Thanks for that.
Cool. Anyone else? No, we're all good. Okay, well, so what I'll do is share some of those links and the Maven commands in the channel. And yeah, if anyone, go ahead.
So Matt, can you hear me?
Yep.
All right, excellent. I got one quick question. I was trying to help somebody out earlier with a Maven issue,
Yep.
and I ended up building the central repository and external feeds, and I built I connected to another repository and external feeds, and there was a difference in the user interface. One, the central feed allowed me to specify extended API, and then the other feed that I used doesn't have that extended API option. Well, do you know what that's about? I can give you the feed because it doesn't require credentials, the other feed, so I can send that across to you real quickly if you want to.
Yeah, if you want to paste that link. I think, so you're talking about in here, the actual user interface had the option to...
Yeah, user interface. So if you go into your central feed right now, you've got your...
Yeah, I think the NuGet one has something about this one here. That's what you're...
Hold on, so let me find the one with the external feed is... Oh yeah, sorry, extended API. So Maven Central, for the URL repo.maven.apache.org/maven2.
Yep.
I've got an option for extended API.
You may not have selected this properly. That should only show up for a NuGet feed. If you select Maven feed, you shouldn't. There's no such thing as an extended API. So it may be that you've pasted this.
You nailed it. That's it.
Yeah.
It still works, by the way.
Oh, really? That's surprising. Okay. I didn't expect that to work. But
without the extended API ticked, it still works. So
right. Oh yeah. The extended API doesn't mean anything for Maven. There's no concept that we put into Octopus. Yeah. So it must just be a mix up here.
Cool. No, that was my mix up completely.
Yeah.
Thanks.
Okay. No problem. Okay. Well, thank you all. I'll grab the recording and put it in the channel when it's done. Thanks for joining.
Awesome. Hey, thanks, Matt. Appreciate it.
See you next time.
Thank you.
Appreciate it. Thank you.